Hello guys, and welcome to the next part in the real-time clock demo that we got going on here for this lesson. What I did is I went ahead and I changed up some stuff. Like I said I was going to, I added some LEDs. So if you look just over here, I just added a couple resistors and some LEDs to RC0 and RC1, just so we can basically kind of recreate that blink project that we did with the timers for the last lesson. We did those timers, and that had the two LEDs that would alternate every 4 seconds. So we're basically going to do the same thing, but we're going to do it with using now the DS1307 Maxim semiconductor part. And so what we're going to do is, so that's all we've done to the schematic. So we will go ahead and jump into MP Labs. So now I'm using MP Labs X again. I'm going to kind of start getting used to everybody seeing that. The main thing that you guys mostly will probably want out of this whole thing is this header file that I've created. This is done with CCS C. I'm kind of in the works of trying to convert this all over to high-tech C. Once I get that done, I may do another video, but it's going to be a while because there's a lot to go through. So this first video about RTCs and whatnot and using the DS1307 is going to be in CCS C for now. I'll look at later, maybe seeing if I can't get this into the high-tech C. But anyway, I'm probably not going to go through this in too great a detail. We're just going to kind of skip through it because you can read through it yourself, because I'm going to post all this on that download link so you guys can download this and use it in your own projects. And so if you find anything you have questions about or whatever, you can always just send me a message or comment or whatever. But I'm not going to spend the time going through all of it because, like I said, you guys can download it, look through it, and see how it's all working. The main things I want to do is I want to hit the highlights of it. Basically, how this is working is it's got this main global variable right here, this GCA DS1307 reg, and it is a giant array, is what it is. And that's what this DS1307 date, time, byte count. If you look up there, it's 7, because there's 7 different pieces. There's seconds, minutes, hours, days of the week, date, month, year, and then there's a control register. And so anyway, that's what makes up this, and this is basically a global. Obviously it's in global variables. It's a global variable. When you include this header file, it will become global, and you will have basically all these registers will be the thing that will be storing all this information. So now what we're going to do is, here's your function prototypes. The functions that are included in here is the set date, the read date and time, the write byte, read byte, bin to BCD, and BCD to bin. These last 4, these guys right here, all these in red, these are basically in control. Just basically functions that call each other and are called by these other 2 functions. So these aren't super important. This is just how we get data in and out of the DS1307 chip. The 2 you want to concern yourself with is these 2. These are the ones we're going to be using. Is the set date and time, so you can actually set the clock, and then the read date and time, so you can actually read and pull the data back out. Now if we jump to the read date and time, the read date and time, how it works is basically, look, it basically reads the I2C bus, it masks off any unwanted bits because it, since it reads the whole thing, there's some bits that you want to mask off, so it's masked. These are maskings is what these are, and then it basically just pulls the registers. That's what it's doing. So it's taking your giant array, calling the seconds register, minutes, hours, day, all that stuff, and storing all of that in that array. Is what it's doing. So this is the reason we have that global array, is that's where you're going to be pulling all of your data. You basically are updating these variables whenever you call that read date and time function. And then the same thing with set date and time. It's going to do the same thing. Get down here the actual function definition. That's exactly what it does, is it stores all of those into your array, loads it in, masks each piece the way it's supposed to be, and then it then does an I2C write, and then just writes all the registers. See, writes all 7, and just writes all that to the to the master, or to the DS1307. So that's basically all you're doing. So the two functions you need to concern yourself with is just these two. Let me get that to go away. Is just these two right here. You just want to set it and read it. So now that we know that, we can go back to our main function. And what I've done here is we set up our, I'm using the 1938 chip, set up our fuses, a little different than RTC C. Basically, instead of doing the config statement, you do fuses. So that's up. Now this one, this is where there's a huge difference, is that the delay that you set up here actually does set the internal oscillator. When you say delay internal and you say it equal to 4 megahertz, it actually does set the internal clock to 4 megahertz or 8 megahertz or whatever it can be set. I think this one can even go up to like 20, I think, or something like that. But anyway, this actually does set it, whereas RTC C, you're just doing a pound define statement and defining it for the delay functions. Here you're actually setting it. Then we go on, we include our header file, our DS1307 header file. It's over here. So we include our header file. And then what I did was, just to make life simpler, I made some define statements real quick. I defined the seconds, minutes, hours, date, month, year, and day of week. And this is what we're going to use to set the date information and time. Then I defined some LEDs, on C0 and C1 was where we had our LEDs. And then now we begin our main function. What I did was I went ahead and declared kind of the same variables up here, this pre-trigger and toggle LED, which we had in the previous lesson. I also declared this mod variable, and I'll show you how that works later. It's a kind of a quirky thing with CCS C. Is the reason I'm having to use that. But output low. First of all, we output low on both LED1 and LED2, so basically make sure they're off. We set up the tri-state register on C to be all outputs. And then the DS1307. Now here's when we go set date and time, and we put in our seconds, minutes, hours, date, month, year, and day of the week. That's what DOW is. And then that will now set. Now what we're going to do is, actually, I need to move this. We're going to enter our for loop. Move that. There we go. We're going to enter our for loop now. And what we're going to do is, now that we've entered our for loop, we're going to read the date and time. So all you have to do, it's a void function, has no parameters. You just declare it. And what that will do is that will go and, as we saw before, the read date and time, it goes and it basically populates our array with the information. It goes and fetches it from the chip. So now that that's all in our global array, we can now begin to use it. And if you remember before, we would always modulus divide the seconds by 4, so we could catch every 4 seconds. We're checking to see if every 4 seconds, it's true, then we do our thing. Well, for some reason, CCS C doesn't like us doing a mod 4 and then equating and then putting it in parentheses and equating that to 0. For some reason it gets angry, so what I did was I just stored that modulus operation in the variable called mod, is what I did. So we're saying if, basically, it's modded by 4, it's an interval of 4 seconds, then we're going to output high on LED2, we're going to output low on LED1, and then we're going to check to see if that same modulus is true and if the pre-trigger is not equal to basically the previous one, like we did before. So that way we don't trigger multiple times because it stays at 4 seconds, because our clock is running faster than 4 seconds. So that way we don't pass it 2 or 3 times, and toggle our deal when we're waiting for the next multiple of 4. We're waiting for 8, and we're waiting for 12 and then 16, and we're waiting for the multiples of 4. We're not hitting it over and over and it's saying, oh, it's mod 4 is 0, so okay. So we're waiting for that. So basically the exact same thing we're doing here. So then we do our XOR, and then we set our pre-trigger, and then we check to see where we're at. And really, honestly, we could get rid of this one. I think that was remnants from before. We could get rid of this one. In fact, yes, let's get rid of this. I think that was from when I started an earlier thing, and then I ended up just copy and pasting the other one. So we'll get rid of that first if mod, because we don't need it. And that's basically it. Now for this, we'll push our build, our little hammer button. We should get a successful build, and we do. And that is all there is to it, ladies and gentlemen. You basically just have to set your date and time with whatever means you do. And the thing that's cool about this is also, once I set the date and time, I could take, and once I ran this on the chip, as long as I have a battery, remember that we can add a battery on. The minute you set this, it has its own internal battery backed up non-volatile memory. And so that battery will keep whatever we set here in the set statement. We'll keep it. And then as you saw on the data sheet, up to 10 years it'll even store it. So that's kind of cool. With a 45 milliamp hour battery, I believe, it'll store that information. So that's kind of cool. So basically you set it, and then you just put inside your for loop, or however you want to do it. You read the date and time, and then it rolls all the information into those registers that we saw in our header file. The seconds, minutes, hours, day, day of the week, date, month, and year, rolls all that into there, and then that's all you got to worry about. And then you can use those just like normal variables. So very, very simple, very easy, very straightforward. And like I said, I will post this code as well as the little header file. Will all be in a zip file for you guys to download from my projects link that's on my channel page. So if you guys want to check that out, that'll be great. Other than that, that's all I have for you guys tonight. I hope you enjoyed this. Happy coding. I should be looking for some more interesting things coming out before too long. Maybe some different modules and different things. I've been looking at buying a couple of other little fun projects to play with, and so there's more on the horizon. So stay tuned. Thank you guys for watching, and take care.